Raza. He is graduate of Center of Excellence, UET Lahore. He will be talking about investigation of hydraulic performance of standard and modified USBR Type 3 Stilling Basin through physical modeling. Hassan Raza, please take care of the time limit, and after 9 minutes, maybe I will be reminding you to conclude the presentation. Please share your screen, and I will request the last presenter to unshare his screen and switch off his camera. Hassan Raza, can you hear me? Can you speak?
Yes, sir, I can hear you clearly.
Okay.
Sir, am I audible, sir?
Yes, I am getting your voice.
Sir, and sir, is my screen is visible to you?
Not at the moment. Yes, now we can see. Yes, क्या है हमारी? Oh, okay, we are showing your presentation from our computer.
Right, sir. वो कह रहे हैं वो अपने कंप्यूटर को शेयर करने के हमारी प्रेजेंटेशन।
Okay, please go ahead,
Uh,
Hassan.
Thank you, sir, for having me. Uh, uh, my my name is Hassan Raza. My research advisor is Dr. Mohammed Clean Server. Please go to next slide. Next slide, please. Thank, uh, Thank you, sir. The topic of my presentation is physical modeling of the hydraulic jump in the USBR Stilling Basin 3, a case study of Mohammed Dam. Now, next slide. The contents of my presentation includes research background, problem statement, research objectives, research methodology, results and discussions, conclusion and recommendations and references. Next, please. Uh, first of all, research objective. Uh, dif- uh, as my topic is energy dissipation in the Stirling Basin with modified design, so different authors have studied the first author Babali et al. Evaluate the hydraulic jump in the basin type 2 using physical and numerical modeling. The comparison of the computed results of the hydraulic jump in the basin with experimental measurements show that in all the discharges, hydraulic jump in the basin with converged wall is better than the parallel walls. And Babali in 2018 investigate the effect of converged walls of Stirling Basin on static pressure using physical and numerical modeling. The results indicated that raise in convergence angle leads to an increase in the value of pressure. Moreover, the results indicated that raise in discharge leads to an increase in the pressure in the outlet in the inlet of the converging Stirling Basin. Next slide. Uh, so further studies were conducted by the Hydraulic Research Center Nandipur using physical modeling. All the experiments were performed on the standard USBR Type 3 Stilling Basin. The approach and entry flow conditions of the spillway remained satisfactory for both gated and free flow conditions. In the basic design of upper Stirling Basin, hydraulic jump swept out of the basin at high discharges, but after modification, like location and size of baffle blocks, aerators, height and length of the basin, jump contained within the basin. Next slide, please. And in the lower Stirling Basin with floor elevation of 355 ASL, the hydraulic jump swept out of reservoir level of 555 meter. However, in the modified design by lowering the basin level to 348 meter ASL, hydraulic jump contained within the basin. Next slide, please. Now come to problem statement. As literature review indicated that with converged walls of the hydraulic jump efficiency inside the basin has improved and jump stabilizes within the basin. Literature review also indicated that increase in convergence angle leads to an increase in the value of pressure. With converging basin walls, the length of the hydraulic jump reduces in the outlet of the basin. Addition of an adverse slope at the end of the sealing basin to increase the energy dissipation by up to 30%. Hydraulic cell 94 studied the hydraulic performance of the spillway and sealing basin by keeping only the standard geometry of the sealing basin. Hence, there is a need to find out how the different modifications in the standard geometry of the basin, type 3 sealing basin, can positively affect its hydraulic performance. Therefore, the lower basin of the moment M spillway is selected as a case study for this research work. Next, please. My research objectives contains to evaluate the performance of the hydraulic jump in the USB sealing basin type 3 and to investigate the hydraulic performance of the sealing basin by modifying the standard geometry of the sealing basin 3, sidewalls and the shape of the baffle block. Next. Research methodology includes model similitude and downscaling, model installation, model validation, and model operations. Next. First of all, model similitude. Physical model was designed by fraud number criteria because of the predominance of gravity forces. In the design of the model, geometric similitudes were observed between the model and prototype by means of geometrical scale ratio of 1:100. These the table shows the different scale ratio parameters of length, discharge, flow, velocity, depth, and pressure. Next. Next slide, please. Sir, please go on to next slide. This is my physical model which I have constructed and installed with the help of official professionals from Nandipur Hydraulic Research Center, and this is the model we have constructed in our empty hall in the CEWRE. First of all, model was installed by installing the spillway crest level at 539 meter ASL. Then upper sealing basin reduced level of upper sealing basin was installed at 460 meter ASL, and then lower sealing basin of 348 meter ASL was installed in the model, and then a downside channel was also constructed to maintain the river water level. Next, please. Next slide. These were my 5 different observation points. Observation point 1, 2, 3, 4, 5. 2 observation points were within the basin, and 3 observation points were downside of the basin in the river level. Next, please. Next slide. Validation of the model was done. Computed values of discharge were taken from the detailed design report of Moment M hydropower project, while the observed values of discharge were taken from the model constructed in the lab. Next slide, please. In order to investigate the performance of the hydraulic jump in the basin, initially model was operated at standard geometry and with the 2 different types of baffle blocks. With this number 1 with the standard baffle blocks, and second with modified baffle blocks, as shown in next picture. And these are the different model operation conditions. Like these are the flow conditions for parallel geometry of the basin. These are the flow conditions for free flow conditions, and as well as for gated flow conditions. We have selected the maximum reservoir level as 558 meter ASL, as you can see in the gated flow conditions, as due to the limitations of the discharge in our lab. Please go to next slide. Next slide, please. Next slide. You can see that these are the 2 different modifications of the baffle blocks at standard walls of the basin. So next picture, next slide. Next slide, please. Now later on, the geometry of the basin was modified to check the performance of the sealing basin. Sidewalls of the sealing basin were converged from up to 5 degree from 1 degree with an increment of 1 degree. Model was operated with modified baffle blocks and then compared with the modified geometry of the basin with the parallel form. Next, please. These were the different model operation conditions for the modified geometry of the baffle blocks. These are the at the left side of the slide we can see that these are the model flow conditions for free flow conditions, and at the right side of the slide we can see the model flow conditions for gated flow conditions. In this way, 40 number of experiments were performed with modified geometry, and 16 number of experiments were performed with standard geometry of the basin. Next, please. These are the model with different converging angle. As we can see at left side, far left side of the picture, one model with 1 degree, model with 3 degree, and model at 5 degree. Model with 2 degree and 4 degree was also conducted. Experiments were conducted, but here I just only show these three pictures. Next slide, please.
Hassan Raza, I request you to conclude in a minute, please.
Right, sir. Please come to conclusions. Please, next. Yeah. Okay. After comparison, the post-jump velocity was 2% less in case of modified geometry baffle blocks as compared to standard baffle blocks, and fraud number values were also in range, and energy loss was higher in modified baffle blocks as compared to standard baffle blocks. Efficiency of the jump was found to be better in case of modified baffle blocks as compared to standard baffle blocks. Please, next slide, please. And here are also some more conclusions. Energy loss increased from 1% to 6% by increasing the converging angle, and best hydraulic performance of the steering basin was observed at 3 degrees conversion of its sidewalls. Efficiency increased up to 4% as compared to standard baffle blocks. Increased in observed pressure value up to 8% due to convergence of sidewalls of steering basin, indicated that energy dissipation in the steering basin has enhanced. Next slide, please. Next, please. Next slide, please. Next slide, please. I have explained recommendations. Due to limited scope of study, model study could not operate at high reservoir level. However, it is recommended to check the hydraulic performance of the steering basin with converged walls. So these are some of my recommendations. Next, please. So these are my presentation from my side. Thank you.
Thank you very much, Hassan Raza, for your nicely made presentation, which was telling us about your results of physical modeling on USBR basin type 3 with some modifications in it.